If you priced a 32 gig RAM upgrade a few months ago, it was pretty reasonable. Check that same kit today, and in many cases it costs hundreds of dollars more. Some people watched prices double in just weeks. Others saw them jump again before they even finished comparing options. That's the strange part. There wasn't a sudden gaming boom. No flood of new PCs launching all at once. No obvious shortage of laptops or phones in stores. And yet RAM prices kept climbing anyway. Here's what that tells us. RAM didn't get more expensive because regular people suddenly started upgrading their computers. It got more expensive because a completely different kind of buyer started consuming memory at massive scale. Today, the biggest buyers of RAM aren't gamers or laptop brands anymore. They're AI data centers. And when those buyers show up, they don't just raise demand. They change what manufacturers prioritize, how supply gets allocated, and what everyone else ends up paying. So in this video, we're going to follow where the memory actually went. We'll break down how AI servers use enormous amounts of RAM, why memory production is being prioritized toward high-end server workloads, and how that pressure spills into the consumer market. By the end, you'll understand what this means if you're building a PC, upgrading a laptop, or buying a pre-built, and how to think about it without guessing prices or chasing headlines. To understand why RAM is getting more expensive, you have to look at who is buying memory now, how they buy it, and why their demand changes everything downstream. The new biggest customer in computing. For years, consumer electronics quietly shaped the memory market. PC manufacturers, smartphone brands, and console makers bought huge volumes of RAM. Their demand followed familiar cycles. Product launches pushed prices up, slow periods pulled them back down. Memory makers optimized for scale and consistency. But that balance no longer exists. Artificial intelligence changed who matters most in the memory market. AI didn't just introduce new software. It created a new class of buyers that operate on a completely different scale. Companies building AI systems don't shop like consumer brands. They don't wait for spot prices to dip or plan around seasonal sales. They plan years ahead, sign long-term contracts, and prioritize guaranteed supply over price sensitivity. These buyers are hyperscalers, cloud providers, and AI labs, and they have quietly become the most important customers memory manufacturers serve. This mirrors a broader shift already happening across AI infrastructure. The AI industry isn't growing like normal software anymore. It's growing more like heavy industry. Big tech companies aren't just shipping updates. They're building massive physical systems designed to run non-stop, filled with thousands of chips operating at high intensity around the clock. That matters because these systems are expensive in ways consumer electronics never were. When you're operating infrastructure that costs billions to build and millions per day to run, small inefficiencies become unacceptable. Delays matter, shortages matter, and paying more for guaranteed components is often cheaper than waiting. So when AI companies buy memory, they don't just buy what they need this quarter. They lock in future supply, they commit capacity, and they change what manufacturers prioritize. This is the point where the rules of the market shift. Memory makers don't stop serving consumers, but consumers stop being the most important customers. Why AI servers consume so much memory. To understand why AI has such an outsized impact on RAM prices, you have to understand how AI workloads behave. Traditional computing tasks are relatively light on memory. Office software, web browsing, even many games load data, process it, and move on. Memory usage rises and falls. Systems get breaks. AI doesn't work that way. Modern AI systems are built around enormous models trained on massive data sets. During training, those models need to keep huge amounts of information immediately accessible. During everyday use, those same models handle millions of requests that rely on fast, repeated access to memory. In simple terms, AI treats memory as a core resource, not background support. If memory is slow, limited, or too far away from the processor, performance collapses. Chips sit idle waiting for data. Efficiency drops. And systems that cost enormous amounts of money to operate stop making sense economically. That's why AI systems are designed to surround compute with memory. Not just some memory, large amounts of it. Fast memory. Memory that stays available continuously. This is also why AI demand doesn't behave like a temporary spike. As models grow larger, their memory requirements grow with them. Once trained, those models don't shut off. They move into constant use, adding another layer of always-on demand. The result is a steady, persistent pull on memory supply. This changes how the entire industry thinks about RAM. Memory is no longer something you add after the fact. It becomes part of the foundation. And when that happens at scale, it puts pressure on the one thing the industry can't easily accelerate: production capacity. Memory factories take years to build and billions of dollars to expand. They can't instantly double output when demand surges. So when AI systems begin absorbing massive amounts of memory, something else has to give. And that's where the consumer market starts to feel the impact. Following the money inside the memory industry. All modern RAM comes from the same starting point. At the base of the memory market is DRAM. It's the foundational technology behind the memory in laptops, desktops, phones, servers, and data centers. Whether that memory ends up in a gaming PC or an AI cluster, it originates from the same tightly controlled manufacturing ecosystem. What changes is how that capacity gets used. Memory factories are among the most expensive industrial facilities in the world. They cost billions of dollars to build, take years to expand, and operate near full capacity even in normal times. That means production is always constrained. When demand rises faster than capacity can grow, manufacturers don't magically make more memory. They decide where the existing output goes. And those decisions follow incentives. Not all memory products are equally profitable. High-end server memory, especially the kinds paired with AI accelerators, commands far higher margins than standard consumer modules. These products are sold in massive volumes to a small number of buyers under long-term contracts. From a business standpoint, they're predictable, stable, and lucrative. Consumer memory looks very different by comparison. It's sold into a fragmented market. Pricing is sensitive. Demand fluctuates with product cycles and retail seasons. Margins are thinner. From a manufacturer's point of view, it's less attractive when capacity is tight. So when AI demand surged, memory makers didn't need to be told what to do. They shifted production toward the segments that paid more and carried less risk. This is an important distinction. The industry didn't run out of RAM, and manufacturers didn't suddenly stop caring about consumers. What happened instead was a reprioritization. The same factories began allocating more output to higher-end, higher-margin memory products tied to AI and enterprise demand. How AI demand squeezes the consumer market. When the largest buyers in a market change how they buy, they don't just absorb supply, they reshape pricing for everyone else. AI data centers don't shop the retail market. They negotiate directly with manufacturers. They sign long-term agreements, and they often pay premiums to secure guaranteed delivery. That effectively sets a new baseline for memory pricing. Everyone else buys around that baseline. PC manufacturers, laptop brands, and consumer electronics companies don't get first claim on output anymore. They buy what's left, when it's available, at prices influenced by upstream demand. This is how a data center decision ends up affecting a gaming PC build. When supply tightens, prices don't rise smoothly. They become volatile. Spot prices move faster, retailers adjust more frequently, discounts disappear because there's no excess inventory to clear. From the outside, this can look chaotic. A RAM kit costs one amount this week, more the next, and even more the week after that. Buyers who wait hoping for a dip sometimes come back to higher prices instead. Retailers get blamed, but they're reacting, not leading. The same squeeze shows up in pre-built systems. When memory costs rise, system builders face a choice. They can raise prices, or they can change configurations. Sometimes they do both, but often, the first response is subtle. A system that shipped with 32 gigabytes last year now ships with 16 gigabytes. The model name stays the same, the price looks familiar, but the experience changes. This is why the impact of AI demand doesn't show up as a single headline moment. It shows up gradually, in fewer sales, in smaller upgrades, in specs that quietly slide backward while prices hold steady. And that brings us to the second effect most buyers don't notice right away: paying more or quietly getting less. Manufacturers know consumers hate visible price hikes. A laptop that suddenly costs hundreds more than last year's model draws attention. It invites comparison. It slows sales. So when component costs rise, brands often look for another way to absorb the increase. That's where despec behavior comes in. Instead of raising the sticker price, manufacturers reduce what's inside the device. Less RAM, slower storage, dimmer displays, sometimes cheaper camera modules or audio components. On paper, the product still fits a familiar price bracket. In practice, it delivers less. This is especially common in mid-range and budget devices. High-end products can justify price increases. Buyers expect it. But entry-level and mid-tier products are built around psychological price points. To hit those numbers, something has to give. The tricky part is that these changes aren't always obvious at purchase. Two laptops can look identical on a shelf. Same model name, same design, same price range. But one has half the memory of the version sold a year earlier. The downgrade only reveals itself later, when multitasking feels tighter or performance degrades faster over time. This is why memory matters more than it used to. Modern software assumes more headroom. Browsers keep more tabs alive. Operating systems cache more data. Games and creative tools rely on larger working sets. When RAM is reduced to hit a price target, the device ages faster. And this effect isn't limited to laptops. Tablets, phones, mini PCs, and even some consoles are affected by the same pressure. They all rely on memory. When supply tightens and costs rise, compromises show up everywhere. None of this means every device is suddenly bad. It means buyers have to pay closer attention. Because in a market shaped by AI demand, the price tag alone no longer tells the full story. The spec sheet matters more. And memory, once the boring part of a build, becomes one of the most important details to check. What this means if you're buying or upgrading. So far, this story has mostly lived upstream. Data centers, factories, contracts, incentives. But all of that pressure eventually shows up in one place, the moment you try to buy or upgrade a device. And this is where it gets practical. If you're building a PC, the biggest shift is how important memory capacity has become. For years, RAM speed got the spotlight. Faster kits, tighter timings, small gains. Today, capacity matters more. Modern software assumes more headroom. Operating systems cache aggressively. Browsers keep tabs alive. Games stream larger assets. Creative apps hold bigger timelines. AI features run quietly in the background. 16 gigabytes still works, but it fills up faster than it used to. 32 gigabytes has become the comfortable baseline for many workloads. That doesn't mean maxing out your RAM. It means underspending on memory is one of the fastest ways to make a new system feel old. Planning to add more later is also riskier now. In a volatile market, prices move quickly and availability isn't guaranteed. Waiting can cost more than buying the right amount up front. Mixing kits can introduce compatibility issues too, especially on newer platforms. Laptops raise the stakes even higher. Many ship with soldered memory, which means what you buy on day one is what you live with for the life of the device. Spec sheets matter more than model names. Two laptops can look identical yet age very differently based on memory alone. This is where shrinkflation quietly hits. A device that used to ship with 16 gigabytes now ships with 8 gigabytes to hold a price. On paper, nothing looks wrong. In practice, it ages faster. Multitasking tightens. Updates hit harder. What felt fine at launch feels cramped sooner than expected. Pre-built desktops follow the same pattern. When costs rise, builders either raise prices, cut memory, or both. That's why labels like gaming or creator matter less than what's actually inside. Memory isn't flashy, but in this market, it's one of the clearest signals of whether a system is built to last or just built to sell. How to think about timing without guessing prices. At this point, the obvious question is whether to buy now or wait. There's no clean answer. Memory production moves slowly, factory capacity takes years to expand, and AI demand isn't predictable. That makes short-term price timing unreliable. A better way to think about it is need, not headlines. If you need a device soon, waiting just to hope for lower prices can backfire. In a volatile market, delays don't guarantee savings. If a system fits your needs, meets sensible specs, and stays within budget, holding off purely for timing carries real risk. If you don't need one immediately, patience can still help. Track specific configurations, not vague price trends. Watch how often they go on sale. Consider last generation or refurbished options where performance is close but savings are real. And always look at the whole system. A slightly older CPU with enough memory often feels better than a cutting-edge processor starved for RAM. The bigger point is that rising RAM prices aren't random or temporary. They're the downstream effect of a shift in how computing works. AI systems consume memory at a scale consumers never competed with before, and manufacturers prioritize the biggest, longest-term buyers. Capacity tightens, prices rise. The impact flows from data centers to store shelves. RAM just happens to be where people notice it first. Thanks for watching. If you enjoyed this and want more deep dives into the future of AI, make sure you hit subscribe and stay tuned. There is a lot more coming.